Jai Shri Gurudev. In this particular class, let us try to find out the centroid of this given figure. Now first, let us draw the centroidal axes. So x axis and then say y axis. Now if you can see over here, x axis and y axis has already been marked. So this is where our origin is going to lie. Next, let us divide this given composite figure into known standard components. So a triangle followed by a quarter of a circle. So it is going to be, let us call this right angled triangle as component 1 plus the quarter of a circle as component 2. Next, let us draw the table. So we have components as the first column, area in square. So this is our second column, x into I in the third column, y into I in fourth column, a into x cube followed by a into y cube. Alright, we have two components. Let us mention the two components, component 1, component 2. So the first component is a triangle, base is 80 and then height is nothing but the radius of this particular quarter of the circle. So this is also going to be 80. So area is going to be half into base into height. So half into 80 into 80, that is going to be 3200. Now quarter of a circle, radius is 80 mm. So what is the area of quarter of a circle? Pi r square divided by 4. Pi into 80 square divided by 4. So that is 5026.548. Next, let us write xi. For the first case over here, the xi, say it is going to lie somewhere over here. So we have always written that wherever the area is going to be more or mass is going to be more, so from that point to the centroid, it is going to be 1/3 of the distance. So it is going to be 1 divided by 3 of the distance, but we are calculating from the centroid. So obviously from the other end, it is going to have a distance of 2/3. 2/3 of the base. This base has to be mentioned over here. If you're taking it along the breadth, it is going to be the breadth, that is base B. If you're taking it along the height or the depth, then it is going to change. So here it is 2/3 into 80, which is 53.33. Next over here, if you remember in the previous classes, we mentioned that the centroid for a quarter of a circle from the point wherever it is, it has a right angle. So there it is 4r divided by 3 pi. But where are we calculating from? From centroid to this point. So from centroid to this point, it is 80 plus 4r by 3 pi. 80 plus 4 into r is again 80 divided by 3 pi. So let us calculate this particular value. It is going to be 113.953. Now coming to yi, this is where the area is going to be more, hence this is 1/3 of d. 1/3 of depth is again 80 mm, so 1/3 of d. So this is 26.67. Coming to semicircle, again coming to quarter of a circle, again this distance is also going to be 4r by 3 pi itself. So this is 4 into 80 divided by 3 pi. So that is 33.95 mm. Now let us calculate a into x. 3200 into 53.33. So that is 170656. The next one, 5026.548 into 113.953. So this is 572790.22. Now A into Y, 3200 into 26.67. So this is 85344. Next, 5026.548 into 33.95, that is 17065.1.3. Let us write summation of area first. So that is 3200 plus 5026.548, which is 8226.548. Summation of A into X, 170656 plus 57270.22. So this is 74346.22, and then 85344 plus 17065.1.3. So this is 25595.3. Now what is the last step? X bar is equal to summation A into X divided by summation A. Similarly, Y bar is equal to summation A into Y divided by summation A. So this is 74346.22 divided by 8226.548, and the other one is 25595.3 divided by 8226.548. So in the first case, we are going to get a value of 8.743446.22 divided by 8226.548. So we are going to get a value of 90.37 mm, and the next one 25595.3 divided by 8226.548. So this is 31.11 mm. So what does this mean? X bar is around 90 mm and Y bar is around 31 mm. So over here, if we are going to take X bar is 90, right? So, and your X bar comes somewhere like this, Y bar is 31, somewhere like this. So this is our centroid, this is Y bar, this distance is going to be X bar. Okay.